Good morning, Stephanie. I'm going to go over this particular question in your homework, and there's another one like it, number 4. I'm also going to go over number 9, which was a multiplication problem that you had attempted and answered incorrectly on your homework. I think I know why you missed it, but let's start with this one. There is a video for this particular problem. Give me 1 second and I'll pull it up. Let's see here. Okay, I'm in the module for the homework 1.4. And the very last video, simplifying square roots and negative numbers, contains information about this type of problem. I'm not going to play the video for you. You can watch it on your own time. I will, however, get to the point where they talk about it. In fact, let me back up for a second. Right here, there's an example that's similar to that one. It might be beneficial to watch the entire video because you have to be able to simplify the square root before you can simplify this expression. But that particular problem, I believe, is at the 9-minute and 38-second mark. And I only know that because I've already pointed this out to another student. Let's see if I'm right. Yeah. Yeah, around the 9-minute and 38-second mark, it goes over a video similar to this one. You literally just texted me. Okay, well, I'm going to continue with the video. So anyway, let's go back to yours. Okay, actually, since you just texted me, I should probably see how your text relates. I can understand when you explain, but do it myself. I confused. I'm really bad with positive negatives. Oh, sorry. Okay. All right. So I think the big picture here as a general problem solving strategy is in order to attack a big problem, you break it down into smaller problems and deal with one issue at a time. It's kind of like when you got 3 or 4 kids all having issues, you got to prioritize and deal with one thing at a time. All right, so the first thing we're going to deal with is the square root of negative 80. And that actually has 2 issues on its own, the negative and the 80. Now, the negative is easy to deal with. Anytime there's a negative under a square root, you can and probably should separate the square root into 2 numbers, one of them being just a -1, because that takes the negative off of the rest of the number. And then by definition, the square root of -1 is I. That's just straight up definition. And then the square root of 80 we'll leave alone for a second. But now the next issue is, what do we do with the square root of 80? Because when you do a square root, like if it were 81, it would be easy. The square root of 81 is 9 because 9 squared is 81. But most square roots don't behave nicely like that. And so when you have a square root that doesn't work cleanly, and if you're not sure if it does, just put it in a calculator and see if the answer is a whole number or a decimal. But when you have one that doesn't work cleanly, then the next question is, can you take that square root and break it down into one number times another so that you can do the square root of a piece of it? For example, we could split the square root of 80 into the square root of 4 times the square root of 20, because 4 times 20 is 80, and the square root of 4 is just 2. But the problem with just splitting it, doing a piece of it, is that it may not be complete, in the sense that this 20 could also be split down and broken apart some more. In fact, the 20 could be split into the square root of 4 and the square root of 5. We still have the 2 in front. The square root of 4 is 2. The square root of 5, we don't know. And now the 2 times 2 in front makes a 4. So the square root of 80 actually breaks down into 4 times the square root of 5. Now, you could also get that if you had made the initial decision to break the square root of 80 differently. Instead of 4 and 20, we could have used 16 times 5. Now, the problem is most people don't just know that 16 times 5 is 80. But had you broken down the square root of 80 that way, the square root of 16 is 4. The square root of 5 we don't know. And that gets us to the best simplification of the square root of 80, because we can't do anything else to make it simpler, in the sense that we can't do anything else to make the number that hasn't been square rooted yet. We can't make that any smaller. I've actually got a separate video on strategies for simplifying square roots like this. But for now, let's just move forward with the square root of 80. And I'll send you the link to the video that shows how to simplify square roots. All right, so we simplify the square root of 80, and we're going to break it down into the square root of 16 times the square root of 5. And again, making that split is not always obvious. So I'm going to show you, I'm going to put you in contact with a video that can show you how to not only split the square root, but split it without making any decisions at all. You just have to follow a procedure. So the square root of 16 is 4, the square root of 5, we don't know. And now we have I times 4 times the square root of 5. But normally when you write a number with an I, you stick it at the end. The one exception is when your number includes a square root that hasn't been completed, in which case the best policy is typically to put the I immediately in front of the square root. You never really want to put it after the square root because then you might accidentally write it inside. All right, so that's the first move. The first move is to simplify the square root. And I'll admit it's a pretty intimidating move to begin with, but let's pretend we get past it. And then your second issue is to clean up this fraction. The rule for reducing in a fraction is you can only cancel parts of multiplication problems, because multiplication and division are opposites, and a fraction is really just a division problem. The problem with this is that we have a minus, a subtraction in the numerator. And since the numerator is a subtraction problem, we really can't do any reducing in this fraction. The typical way to fix this when there's an addition or subtraction problem in the top is to split this into two separate fractions by splitting the numerator into individual terms and giving each term the same common denominator. This is literally just unadding or unsubtracting fractions, where you reverse the process for adding and subtracting fractions, which is get a common denominator and combine the tops. Well, we'll just split the tops back apart and keep the common denominator. And once you split it into two separate fractions, then you can just reduce them individually by looking for a number that will divide both the top and the bottom evenly. I'm just kind of cleaning this up a little bit because I'm making some room. Okay, I can just redraw that. Sorry, I don't mean to waste time organizing things, but this is what happens when you make a video impromptu. You kind of play around with things. All right. Now on the first fraction, we have a 3 in the numerator right here. I know it's negative, but it's not going to do anything. We got a 48 in the denominator. If we divide both sides by anything, it can only be 3 because of the 3 on top. 3 is only reducible by 3. 48 is also reducible by 3. If you weren't sure of this, you could check in the calculator. And so the top becomes -1. That's -3 divided by 3. And the bottom becomes 48 divided by 3, which ends up being 16. Now, in the second fraction, we have a 4 and a 48. And if you're worried about reducing the 4 because it's got all that other stuff attached to it, it's got the I, it's got the square root of 5, it's okay, because the rule for reducing a fraction in a fraction is you can reduce any parts of multiplication problems. The top of the second fraction is 4 times I times the square root of 5. It's one long multiplication problem. Every piece of that multiplication problem is eligible to be reduced, including the 4. The second fraction, we're going to reduce by 4. And again, if you're not 100% sure if 48 is divisible by 4, a calculator would know. All right, we still have the minus in front of the fraction. When we reduce 4 divided by 4 is 1. We still have the I. We still have the square root of 5. And on the bottom, 48 divided by 4 ends up being 12. Now, this is a perfectly acceptable answer, and the homework would accept it. However, there's one small part of it that's unnecessary, and that's the 1 on the top of the second fraction. Because on the top of the second fraction, we have 1 times I times the square root of 5. Well, 1 times anything is itself. So I guess another way of looking at it is we can actually do the problem 1 times all that. 1 times all that is just all that. So we don't really need the 1 on the top of the second fraction. So I'm going to get rid of it. It's not wrong to leave it there. It's just unnecessary. We do need the 1 on the top of the first fraction, though. All right. I will send you a link to the video that talks about simplifying square roots in more detail, but there's that question. But I also want to take a look at question number 9. So let me pause the video and get that ready. Come on, pause. Why is it not pausing? There we go. It's you skip 3 and 4 like I'd recommended so that you could get some more of the homework done. And when you got to number 9, you got an answer that was wrong, but I think I know why it was wrong. Well, actually, let me share it with you because I've got the screen here. And by the way, this video on YouTube is not public, which means the only way anybody can view it is if they have the link. I'm not sharing the link with anyone. If you want to share the link with someone, that is completely up to you. This is your question number 9 on homework 1.4. You had said, actually, that's the correct answer. The answer that you gave was -2 plus 17i. And even though I can't see your work that you did to get there, based on your answer, I think I know exactly the mistake that you made and how to fix it. Okay, so let's go back to the whiteboard. Yeah, I think based on your work, you did correctly FOIL the problem, meaning that you did first, outside, inside, last. Let's color code this. The first part of the product is -1 times 2, which is -2. The outside of the product, hold on, I have my formatting issues. I need to fix those. Okay, the outside part of the product is -1 times I, which is -1i, or just -i. We'll leave the 1 there for a second. The inside part of the product is +6 times 2i. Well, positive times positive is positive. 6 times 2 is 12, and then there's an I in that product. And then the last part of the product is where I think the mistake was made. I'm going to be a little bit more specific here on the last part of the product. It's +6i times +i. And you'll notice I'm bringing the plus with everything. Inside of the parentheses, the plus actually is an addition. But whenever you multiply with a term and an expression, if it's positive or negative, it keeps its sign as you mess around with it. When it's negative, like it is here, it's critical to keep up with that sign. Most people don't keep up with the pluses, though, and it's okay if you don't. But I like writing the signs down anytime I bring out pieces of a problem so that I don't accidentally mess up a sign. All right, and when you multiply these, there's 3 things to concentrate on: the signs, the numbers, and the i's. Sign-wise, it's easy. Positive times positive is positive. Number-wise, it looks like the only number there is 6, but the second term does have an implied 1 in front of it. 6 times 1 is 6. And for the i's, we have I times I, but I times I is I squared. That's literally what it means to square something, to multiply it by itself. The mistake I think you might have made was you might have just put +6i here. Because if you did, then you would end up getting the answer that you had typed in, which was, let me go back to the, let's see here. The answer you typed in was -2 plus 17i. And in this problem, as is, if you combine all 4 of these pieces, you do get -2 plus 17i. However, the last part of the FOIL process is not +6i, but +6i squared. Now, you may or may not have written the square on it. If you left the square off, you probably combined like terms and got the answer that you got. If you wrote the square, you still might have accidentally combined all of these, but those are not all like terms because the third term has an I squared, whereas the first 2 terms have just an I. Okay, so on the assumption that you left off the square when you FOILed, here's what would happen next. Well, here's what would happen next regardless. Part of the multiplication process with imaginary numbers is knowing this. Excuse me, not knowing that. That's just what it means to square something, is knowing the following. Let's get rid of that. Sorry that I had the eraser. By definition, and this is it's like the whole genesis of this entire section. I'm going to make this format the way I want. There we go. I squared is equal to -1, which really blows some people's minds because most people say, well, when you square a number, it comes out positive. Well, that's if you square a real number. I is an imaginary number, as explained in the first video of the series. But what this really means is the following. This statement means if you see I squared, and this is how I have to type I squared because the word processor inside of this whiteboard will not allow me to type superscripts. But if you see I squared, change it to -1. That's like a commandment in this section. If you see I squared, change it to -1. If you see I squared, change it to -1. If you see I squared, change it to -1. Well, I see an I squared at the last part of my FOIL process. That means that the tail end of the FOIL process changes to +6 times -1. But +6 times -1 is -6 because positive times negative is negative. Let's put that in black because I'm going to bring it all back to monochrome. Because remember, we're in the midst of this FOIL process, which means that we still have this -2 up front, this -1i, followed by the +12i. And then we have the -6, which I'm going to place a little bit more linearly with the rest of the black line. There we go. All right. So at this point, now we just have to combine like terms. There's no more simplifying the individual terms. However, we can combine the parts without i's and we can combine the parts with i's. The parts without i's are -2 and -6, which together give -8. And then the parts with i's are -1i and +12i. And when you combine like terms, meaning same letters with the same powers, you leave the letters and powers alone. You just combine the numbers in front. So we're going to combine the -1 and the +12. That will give us +11, because when you add a positive and a negative, they work against each other. So you subtract, and then the larger number, in this case 12, determines the sign of the result. But they were like terms and they all had i's, so it still has an I on it, which was the correct answer to the problem. At least I'm pretty sure it was, unless I made some egregious error. Let's go back and check it real quick. Yes, -8 plus 11i. All right, so hopefully this will allow you to get through numbers 3 and number 4. And I'll be honest with you, Stephanie, if you get everything except those 2 questions, you're going to be fine for the majority of this chapter. But with this multiplication correction, either remembering to make the I squared when you multiply 2 terms with i's, or remembering that I squared, or rather I should say, and remembering that I squared is -1, and then you just push the problem until it can't be simplified anymore. This should allow you to get through most of the homework pretty easily. When you get to the last 2, I think it's questions 14 and 15, the division problems, it's not intuitive how to start it, but even when you know how to start it, it's quite the path from the beginning to the end. You can see that in the video in Canvas about dividing complex numbers. All right, I hope this helped. And if you have any other questions, or if there's anything else I can do to help you, just let me know.